Hey, what's up? I'm just going to get right into it. This is Physics, Chapter 3.1, page 110, question 2. So, use a string to suspend a cork ball with a mass of 22 grams from the ceiling of a moving speedboat. The ball and string hang at an angle of 32.5 degrees from the vertical. Calculate the magnitude of the speedboat's acceleration. So, here's my little sketch. Here's the ceiling of the speedboat. Here's our string and our cork ball. It says they hang at an angle of 32.5 degrees from the vertical. So if this is our vertical, then the 32.5 degrees will be here. In order to find the acceleration, we have to find where the F net is. So we'll split this into our y component and our x component, and we'll also consider our force of gravity, mg, in order to find our acceleration. So the first thing we know is that since the ball isn't moving up or down, we know that the sum of the forces in the y direction is 0. So what this means is that, oh, never mind, let me go back here real quick. So this is our force of tension. From here on out, I'm just going to call it T. So T, this is our total force of tension. We're going to split it into our x and y components. So this will be, this is the cos along the angle. So this will be T cos theta. And this is our sine, because it's opposite of the angle. And here's the hypotenuse, so this is our sine. So this is T sine theta. Going back to this now. So we know that the sum of the forces in the y direction is 0 because the ball is not moving up or down. The forces that we have in the y direction are T cos theta and mg. So we know that T cos theta, which is our positive value, minus mg, which is our negative value, going down, will equal 0. What this means, what we can do here to rearrange to find T cos theta, and we can put mg on the other side, equals mg. And then to isolate T, divide T cos theta by cos theta, and that'll get mg over cos theta. Now we have the theoretical value of our force of tension. Now let's go to the sum of the forces in the x direction. So we know that the sum of the forces in the x direction, since the ball is not moving up or down, the sum of the forces in the x direction is the F net. And the only force we have in the x direction for this question is T sine theta. So F net equals T sine theta. Here we found the value of T. So we're going to plug that in, because that'll get rid of that unknown value. So where T is mg over cos theta, and then it's still multiplied by sine theta. So that's what we have now. Sine theta over cos theta is the same thing as tan theta. So now we're going to write F net equals mg tan theta. Now, we know that F net, in order to find, another way to find F net is to do F net is equal to the mass of an object times its acceleration. So since F net is equal to ma, mass times acceleration, instead of writing F net here, we're going to write ma. And that equals the same thing that we had here. So mass times gravity times tan theta. Now, although they gave us the mass, where is it? Here. It asks, do you need to know the mass of the ball to make this calculation? And really, you don't need it, because here we could just cancel out these masses. They're unnecessary information. So that gives us A equals G tan theta, and if we plug in our given values, we know that A is 9.8, which is force of gravity. I'm not going to put units until the very end, because I just don't like to do that, times tan 32.5. So our A is going to equal 9.8 times tan 32.5, 6.24. Also not going to worry about sig digs, because that's not what this channel is going to be about. So our final answer is that the acceleration is 6.24 meters per second squared, and that's their answer here. So for 2B, they say determine the magnitude of the tension in the string. Do you need to know the mass of the ball to make this calculation? Why or why not? So there's two ways we can do this. Yes, there's two ways we can do this. The first thing we can do is we can sub in the mass and the angle here, and that'll give us the force of tension. And then we could also do F net equals MA to find the... Oh, so sorry. Never mind. We can't do this. We're going to do this one. So T equals... Because if we do that, we only get the... I guess I should explain that. If we use this, F net equals MA, then we're only getting the F net. We're not getting the force of tension. We're looking for this force of tension. So this tension, or force of tension, is equal to, from this equation, mg over cos theta. T equals, the mass they said was 22 grams, which is, 0.022 kilograms times 9.8 over cos 32.5. So our tension is going to be 0.022 times 9.8 divided by cos 32.5, which is 0.26 newtons. So the force of tension, I'm writing T, but it means Ft, it's the same thing. The force of tension in the string is 0.26. There's our 0.26. Alrighty, see ya.